Hi, I am Judy Madulara and this is my video presentation for Numerical Method Laboratory Plate for Activity 1 and 2. So in Activity 1, from Lesson 8 handout, Exercise 8.2, we are tasked to create a function program named myInvCheck, which is the script file name seen in line 1. We have this function residual is equal to myInvChecked n, which returns the scalar residual from a function n by n matrix by inversing and multiplying. So the variable a is equal to the RANDN n comma n. It creates a random matrix. And the variable b calculates the inverse of a, which has the command of inv a. Then a and b manipulate multiplies a inverse using the command a asterisk b, and residual. With this statement, it calculates scalar residual using Frobenius norm, and the end command it indicates to terminate the command or the code. In Activity 3, Exercise 8.3, we are tasked to create a MATLAB script program named myInvCheckPlot that calls the myInvCheck from the previous activity for n is equal to 2 to the power of I times 10. So here we have this script program where n is equal to the empty bracket where the empty matrix of n, the residual of n, and then the same goes as the residual because we are going to define it later. And then for this for loop, I is equal to the 1 to the power of 1 colon 10 as we took I from 1 to 10. Then ni is this variable. It calculates the n where 2 to the power of I times 10, and the residual I, which stores the residual corresponding to n, and the end command which terminates the code. So in command window, I command the MATLAB the format compact so that the values won't take too much space. Then calling out the program to plot the data which we created recently, this myInvCheck plot, and then this log n comma residual. This command plots the y and x coordinate using a base 10 logarithm scale on x and y axis. So on, we've created this plot. As we can see that as n increases here in x-axis, the residual also increases here in y-axis, which mostly linear on log scale. From this, we can infer that as n increases, the scalar residual increases exponentially. Note that this graph may differ because there is a random array. And that would be all. Thank you.